And welcome again. This is the third example. I can give you many, as many you want. This is the third example of motion with constant speed along a straight line. And this is also a simple problem. You can see two cars were moving at constant speeds V1 and V2 on the roads intersecting at right angle. I mean, here. These are the two roads. One line is AB and the second one is perpendicular to it, in which the arrow for V1 is drawn. So two cars were moving at constant speeds V1 and V2 on roads intersecting at right angle. When the first of them reached the intersection, that means here, the second had to travel a distance L. It is L distance behind. पहला वाला यहाँ पहुँच गया, दूसरा वाला भी यहीं पर है. आफ्टर वट टाइम टी द डिस्टेंस बिटवीन द कार्स विल बी मिनिमम. कितनी देर के बाद, क्योंकि ये तो आगे बढ़ता जाएगा, इसके आने का वेट तो करेगा नहीं कि दोनों के बीच का डिस्टेंस ज़ीरो हो जाएगा. तो इन द कोर्स ऑफ मोशन द प्रॉब्लम इज बीइंग आस्क्ड फ्रॉम यू दैट आफ्टर वट टाइम टी द डिस्टेंस बिटवीन द कार्स विल बी मिनिमम एंड वट इज दिस मिनिमम डिस्टेंस. ओह, देयर आर टू क्वेश्चंस. सो आई थिंक मिनिमम मैक्सिमम तो स्टूडेंट्स जो हैं वो शुरुआती वो कुछ डिफ्रेंसीशन वगैरह सीखते हैं और उनको लगता है कि मैक्सिमम मिनिमा यूटिलाइज करने का टाइम आ गया है, तो दे स्टार्ट सॉल्विंग लाइक दिस. आई कैन गिव यू टू सॉल्यूशंस फॉर दिस. द फर्स्ट वन इज सॉल्यूशन वन एंड in solution 1 I hope you can determine the distance between the cars at time t. तो टाइम t के बाद टाइम t आफ्टर द फर्स्ट कार हैज़ पास द इंटरसेक्शन. पहला कार जो है ना, जो यहाँ से पास कर चुका है, उसके t टाइम के बाद दोनों कहाँ कहाँ होंगे. तो ये कहीं आगे बढ़ गया होगा और ये कहीं यहाँ होगा. तो ये एक्स एक्सिस इसको मान लो, अगर आप चाहो थोड़ी देर के लिए इसको वाई एक्सिस मान लो, तो इसका एक्स कोऑर्डिनेट होगा एंड एक्स कोऑर्डिनेट विल बी सिंपली ये डिस्टेंस भी टी टाइम में v2 स्पीड से ट्रेवल कर रहा होगा, तो ये डिस्टेंस v2t होगा. सो इसका एक्स कोऑर्डिनेट, इस पॉइंट का एक्स कोऑर्डिनेट होगा सिंपली l माइनस v2t. और ये तो v1 स्पीड से जा ही रहा है, अभी t टाइम के बाद यहाँ पहुँचा होगा, तो इसका y कोऑर्डिनेट होगा सिंपली 0 v2t. मतलब एक्स कोऑर्डिनेट 0 क्योंकि वाई एक्सिस पर है, और यू कैन सी हियर कि वाई कोऑर्डिनेट इतना होगा, तो इसका वाई कोऑर्डिनेट 0 होगा. ऑफ कोर्स लीव इट, यू नो दैट. सो यूजिंग डिस्टेंस फार्मूला, सिंपलेस्ट फार्मूला, डिस्टेंस फार्मूला, you can at any time t you can find the distance between the cars, and that will be s equals under root v1t square plus l minus v2t whole square. That is going to be the distance. And now since it's a straightforward problem, it remains to define the minimum value of the function st. S is given in terms of time for t is greater than equal to 0. So this can be done by calculating the derivative ds by dt, and you can transform it everything else, because s can be written as simply as if you check this, just break the square and you will get a result something like v1 square plus v2 square multiplied by t minus 2l v2 t plus l square. If you break this square and manipulate the things a bit, you can also write it, you can manipulate it like this. You can take out v1 square plus v2 square as common, and you will get the result something like t minus L V2 divided by V1 square plus V2 square, and plus L square divided by V1 square plus V2 square. If you take the pen to take out V1 square plus V2 square as a common, and you know now how to differentiate and get ds by dt, and obviously just put the ds by dt equal to 0 and you will get your time. I'm not going to differentiate for you, you have to do it. I don't do such things, so you can get your time, because ds, just find out the value of ds by dt and put it equal to 0, and you will get the time as L V2 divided by V1 square plus V2 square, and corresponding value of S, that is the minimum distance, let's call it S minimum. You are going to get it like something L V1 multiplied by under root V1 square plus V2 square. But look, this is calculus. If you don't know the calculus, no need to worry about. I have a second solution for you, call it solution 2. Because the task is complicated by the simultaneous movement of both cars, so the solution will be much easier if you place your observer at one of those cars. Because look, you have two cars. Let's call it this is car B, second car, and this is car A, the first car, and this is moving in this direction. V1 is its velocity, and this is moving in this direction, and V2 is its velocity. Both velocities are perpendicular, we know, and the distance between them at the initial moment was L. When this car reaches to this position, the point, this is the intersection, this car was L length behind on a perpendicular side. So I'm going to make the driver of one of the cars as an observer, or I'm going to call it, let's connect a reference frame with the first car, with this car. This car is the observer, and if this car is the observer, that means you are out of the picture. This car is the observer, and for this car the velocity of car B will be simply as V2 minus V1. The object should be placed first and observer behind it, and let's call it V2 vector, because difference of two vectors is a vector. And yes, and of course in this frame, velocity of relative velocity of first car, the velocity of first car is equal to 0, because the observer is moving with this car, so there is no change in position of the first car with respect to an observer sitting here. So if you like, I can also write at relative velocity of car 1 with respect to the observer sitting at A is equal to 0, and this is the velocity of car B with respect to the observer sitting in car A. And we also know the value of V2 will be equal to under root V1 square plus V2 square. Why? Because you can see here, you can draw a diagram for this. This is capital V and this is a small v. You can draw a diagram for V2 minus V1. So put V2 here. V1 is here, so you can draw a line for minus V1 in this direction. And V2 minus V1, since V2 vector V2 minus vector V1 is V2 vector plus minus V1 vector. So you need to add them, v2 and minus v1 vector, and that is going to be your relative velocity of car B with respect to car A, the driver of velocity of car B with respect to the driver in car A, and these are lengths. Arrow of this length is b2 and arrow of this length is b1, and both are perpendicular. So magnitude of b2, that means arrow of this length, it's simply under root b1 square plus b2 square. So it's simple. And the rest of the things, what to do next. The whole picture is here. Here is car A and here is car B at the initial position, and B is moving with velocity v2 in this direction, and A is moving with velocity v1 in this direction. And for the car A, for the observer sitting in car A, the velocity is v2 minus v1. This is obviously v2. If you can draw a full arrow for v2 and minus v1, then this is v2 minus the arrow for v2 minus v1 vector. And for this observer, the car is moving on this line. And this is a sitting duck. This observer is sitting here and watching it, nothing else, because an observer is always rest with respect to itself, because his position cannot change with respect to himself. So this is a point and this is the line, and you need to find the minimum distance. So I don't think you can do anything except drawing a perpendicular line, or this line, or a perpendicular on this line, and this will be your minimum distance. And if you want something else, just assume that this angle is theta, and try to use the bigger triangle, because there is not just one right angle triangle, but there are two right angle triangles. So use the bigger triangle AB, including AB and S minimum. Just try to find out the value of sine theta, and sine theta is perpendicular by base, that is S minimum, this length. This is the length triangle. So this is S minimum and this length was L. So sine theta is equal to S minimum by L. And from this triangle, you can get your sine theta as well. And from the smaller triangle, this triangle, the value of sine theta is nothing but perpendicular is V1 divided by hypotenuse is vector v2 minus vector v1, the length of vector v2 minus vector v1, which is under root v1 square plus v2 square. And you can also find cos theta from what? Though you can get just equating the values of sine theta from these two equations, you have got already your S minimum without differentiation, without anything else, and you can just equate these two values and you will get S minimum equals L V1 divided by under root V1 square plus V2 square, and this was quite simple to get. Now if you want to find the time, then you have to do one more thing. Suppose the name of this point is D. So you started from here for this observer. Remember, your observer is here and you are moving on this path. So For your observer, you started from here and moved to this point till you reach to the minimum approach distance. So for this observer, you traveled the distance BD. So with a speed under root b1 square plus b2 square, because on this path you are using this velocity to move from point B to D for your observer. So time taken to reach from B to D will be simply as distance BD divided by magnitude of length of this vector b2 minus b1, which is obviously under root b1 square plus b2 square. Now, how can you find BD? BD, you can use the length triangle again, because you want to find a length. And since this angle is theta, this is perpendicular and this is base, but you know you have the value of hypotenuse now, though you have the perpendicular as well. So you can use anything to find BD, but just like I started this problem, I will use this length BD and this length, and this is base and this is hypotenuse. So you can calculate cos theta to find BD, and cos theta will be simply base, that is BD by hypotenuse L. So, and next you can find cos theta from this smaller triangle as well. And for this theta, this is the perpendicular, this is the base, and this is the hypotenuse. And so cos theta can be written as base is B2 divided by hypotenuse is under root b1 square plus b2 square. And you can get your, by equating these two equations, two expressions, you can get the value of BD. And find out the value of BD and find the time taken, and time taken you are going to get same as before, that will be LB2 divided by B1 square plus B2 square, and that's simple. So this is called the change of frame, nothing else. Why change of frame? Because changing frame sometimes provide a much simpler solution. Why should I do this? Because I think this is the simplest thing in this world. So why don't you use this? But I have just learned how to differentiate where I am going to use it. Yes, you are free to do it, but just don't make mistakes while differentiating. Just improve your mathematical skills, and this is done. This is simple thing. What I am doing here, I am doing my job. My job is to talk to people, provide them different ideas, try to share different ideas with them, how to solve a problem, how to approach a problem, and nothing else. So these are constant speed problems. Yes, these are constant speed problems. And if you like, I can provide you many more like this, but not today. In later videos, I'm going to provide many more like this. So you just have to watch those videos and try to understand the things, try to develop your own approach, your own point of view. Because I'm not teaching you, I'm not telling you that you should do like this. I'm providing you options. You choose yours. Thank you very much.